up, everybody? InstructaBeats back again on the train to linear equation greatness. We are at linear equation video playlist number 3. Today we are going to be determining if the value of x given is in fact a solution. So let's hop on this train track and find out where it's going to take us today. Our objective today I will be able to determine if a value given for x is a solution for a linear equation. So typically when you think about algebra, and maybe you've been talking to other people, you're solving for what x is. Well, today's the first step of that. Today we're going to be asking you, we're going to be giving you different numbers to try to plug into your equation for x, and you get to tell us whether or not it is a solution. So if we remember back to our first lesson, at this point in what we know about linear equations, we can assume that our equation is balanced, right? And so this is where we get our balanced scale from that you can see right here, right? And we have our two expressions on either side of the equal sign, and the equal sign is like the middle of the scale, right? And so we want both of our sides, both of our expressions, to be equivalent to each other. That means that there should be a solution that we can plug in for x that is going to make these two sides stay balanced, right? So in this lesson, we're going to be giving you a couple different solutions, and you're going to plug them in to check to see if they are a solution to our equation. This is going to be an important skill for you later because in our next lesson, you're going to get to start solving for what this variable is. But at the end, we always come back and we check it. We do what we call a check, and we plug in the number for the variable to make sure that in fact our balance is balanced, right? And so this is going to be a really important step for you to understand what you're doing, okay? So the first thing we want to do, we want to check, is 2 a solution to this equation? So anytime you see an x, we're going to plug in a 2. Now for this one, there's only one x, which makes it a little bit easier, right? So I'm going to rewrite this as 4 plus 15 groups of 2, and that equals 49. So this one's not too hard because there's only one x to plug in. Obviously, when I use my order of operations, I need to multiply first to solve that. And we can see here that we have 34 equals 49. And I'm sure you already know this, but as you can see in our visual underneath, these obviously are not equal. So 2 was not a solution because it did not keep our scale balanced. It didn't make the expressions equal to each other. So we would say that 2 is not a solution. So now let's erase that and let's see if 3 is in fact a solution, right? So I'm going to plug in, anytime I see an x, I'm going to be plugging in a 3 for that, okay? Equals 49, and I see that 4, and obviously 15 plus 4, 15 groups of 3 is going to be 45. And I try to keep my equal signs underneath as much as possible. The hardest part about linear equations is being neat. And when I add these together, I can in fact see that 49 is a balanced scale. The expressions are equal to each other when I put 3 in for x. So we would say that that 3 is a solution for this linear equation. Okay? So this is what we call a check. We're checking to see if the solution we found works to make sure that our balance is still in fact balanced. But today we're just giving you the solutions for you guys to check. So here we have 8x minus 19 equals negative 4 minus 7x, okay? And just like we talked about before, we think of these linear equations as a balanced scale. So we want to make sure our expressions, just like it shows you in the picture, our expressions are going to be equal to each other. So we're going to figure out, does 5 make our two expressions equal to each other and balanced? Okay, and so we're going to do, anytime we see an x, we're going to put a 5 in. So for this one, we have variables on both sides, and that's okay. Okay, pretty easy. Minus 7 groups of 5. And I'm going to solve out each side of the expression at the same time. So I have 40 minus 19 equals negative 4. Now I know that negative 7 times 35 is still negative 35. And then when I subtract that, okay, right, that'd be 21 over here. Now negative 4 minus negative 35, again going back to my negative number rules, is going to be negative 39. So 5 is not a solution. Let's cross that out. Boo, 5, because it didn't keep our scale balanced. Let's try 1. Voila, magic, and everything's gone. So now we want to see if 1 is a solution. So I'm going to put in 8 groups of 1 minus 19 equals negative 4 minus 7 groups of 1. Obviously that's going to be 8 minus 19, negative 4 minus 7. Now when I have positive 8 and I'm subtracting 19, I want to make a 0. And so if I take away 8 from 19, right, it's going to leave me with 11 left over, which is going to be negative 11. So I have negative 11, and then minus 4 minus 7 is also negative 11. So just like our friend tells us, great job, we know that this is in fact a balanced equation. So we are going to say that 1 is a solution, okay? So hopefully you got that one correct. If not, it's okay, right? It's okay to fail as long as you learn from it. So we're going to continue. This is a skill we're going to continue to practice as we go throughout our playlist because, again, anytime you find the solution yourself, you're always going to go back and check it using what we just did. We substituted a solution in for x and then solved to make sure that our equation was balanced. And if it wasn't, we said it was not a solution. And if it was, we threw a little party and we said it was a solution. Thank you so much for checking us out today. We really appreciate it. Please check out the rest of our linear equation playlist. You can follow us on Instagram at InstructaBeats. As always, please like and subscribe the video. Even if you didn't like it, still like it. Help us out and push that little red subscribe button. Please check out our other videos and songs at InstructaBeats Official. Thank you so much for spending time with us today. InstructaBeats, out.